Welcome to the third and final part of lesson 1.5. Today we will be being able to solve compound inequalities. And compound inequalities are inequalities that have two parts and are usually connected with an and or an or. The and means that the solution must be true for both inequalities. An or means that the solution must be true for one or the other inequality. Alright, so here's an example. A number is greater than 5 and less than 10. So this is an and expression. So let's just think about what are some numbers that are greater than 5 and less than 10. Well, I'm thinking of the number 6. 6 is greater than 5 and it's less than 10. 7 is greater than 5 and less than 10. So if we write this inequality out in expressions, x is going to be my variable, and x is going to stand for a number. So a number that is greater than 5 and a number that is less than 10. So here's it written out in expression. Another way to do an and is to put it in compound form. And we're going to put one expression with two inequality symbols. So this number needs to be x is less than 10 and greater than 5. So here's an and statement written in one piece. And then we have an or. A number is greater than 2 or less than -1. So I'm going to let y be a number. So this number can be greater than 2 or a number less than -1. So it has to fulfill one or the other. So like 8. 8 is greater than 2. -5. -5 is less than -1. Both of them work because this is an or statement. It has to be true for one or the other statement. So to write this out in words, y has to be greater than 2 or y has to be less than -1. And notice that 8 fits into the first inequality and -5 fits into the second inequality. So an or, it has to be true for one or the other. An and, the solution has to be work for both of them together. Alright, so we're going to try to find the solution to 7 is greater than 2x and 3x is less than or equal to 18. So this has to be true, the value of x has to be true for both of those. So we're going to take them individually and we're going to solve them separate first. So 7 is greater than 2x and we're going to solve for x. So I'm going to divide both sides by 2. And x ends up being less than 3.5. If I want to switch that around so that my x is on the left, I have to flip the sign. X has to be less than 3.5. Then we need to work for the second part of the and. So x has to be less than 3.5 and if we solve the second equation, x has to also be less than 6. So here's our statement, which means that x has to be less than 3.5 and x has to be less than 6. So we're going to take and graph each of those on a number line. So here's my number line, and here's my 3.5, and here's going to be my 6. So 5, 4, 3. And we're going to graph them individually. So I'm going to do this one in red. So x is less than 3.5. So I have an open circle because it's less than, and less than goes to the left. So here I have the first part of our and then I'm going to do in green, x is less than or equal to 6. So less than or equal to means we need to fill in the circle, and it's also less than or equal, so we're going to go to the left. So now represented in our graph, we have a couple of things. First of all, in the graph form, the place where our colors overlap is the solution to the inequality. So this part right here is where the two overlapped. So that's the solution to our inequality. So I would like you to pause and try this one on your own. Alright, it's time to correct. So we're going to solve both of these separately, and then we're going to graph them. So I'm going to start with adding 1, divide by 3, and x needs to be greater than or equal to 2, and x has to be less than 6. So here's the solution to my and compound inequality, and then let's graph it. So 6, 2, 0, 2, oops, hold on. 2, 3, 4, 5, 6. Okay, so let's graph the x. If you want to switch it around, x is greater than or equal to 2. So here's 2 filled in because it's greater than goes to the right. And then x is less than 6, so less than is open, and less than goes to the left. And now the places where they overlap is between 2 and 6. So including 2, but not including 6 because it's not equal to 6. All right, so on to an or. So what is the solution to 7 plus k is greater than or equal to 6, or 8 plus k is less than 3? So again, we're going to solve them individually. So I'm going to subtract my 7 over, and I'm going to subtract my 8 over in my second one. All right, so the solution to our or written out in expressions is k is greater than or equal to -1, or k is less than -5. So on my number line, we have -5, -1. K is greater than or equal to -1. So filled in circle for greater than or equal to, and greater than goes to the right. And k is less than -5. So open circle, less than goes to the left. All right, now, since this is an or, the solution to the graph is any part that has any sort of writing. So we could pick a number to be a solution that's less than -5, so this part works. And this part works because the number could also be greater than -1. So both parts of the graph, no matter what is on the graph, all of it is part of the solution because it's an or. For an and, it's the part where the two overlap because both parts have to be true for the inequality. All right, and I would like you to pause and solve this one on your own. All right, let's solve it. So we have 7w plus 3 is greater than 11. I'm going to solve this one real quick. W is greater than 8/7. And then the second equation, or inequality, I mean. W is less than -3. So this is an or. So there's our expression. -3 here, and 8/7 is just over 1. All right, so let's graph. W is greater than 8/7, so greater is open and to the right. W is less than -3, so again open and to the left because it's less than. So again, both pieces of this inequality are the solution because it's an or. All right, and that concludes lesson 1.5.